straight lines. Very simple technique, not really that hard. Um, well, kind of maybe need to decide to erase some of these just because it's a little bit bad over there. But yeah, generally that's the idea of it. Hide this. So we're gonna do a new one over here. We capture this, put it into this format. We go over here. Generally, I had to remember all this. So um, first thing I would say is this is wavelength. I also need to remember what the amplitude and how that interacts with the light. So V is just frequency here, but so all right, V equal frequency, I believe. And then because this is how it turns out, this was on a test question. Basically, label this wave. For some reason, my professor thought it was a good idea to put this in here, which I'm still confused about why the hell this was in my test. So actually, I'll use this thing. So basically, the idea was you had to label this as uh, amplitude. Yeah, I have no idea why they thought this was a good question. Um, but since it was on my test, I will show it off. The professor didn't ask for any numbers either, just the idea of it, which I guess that makes sense. I don't know. But I personally still have no idea why my professor said this is a question I gave. So what the question was basically you needed to show the so the characteristics of the wavelength, the electric field, and electric field wavelength. Um, I'm still slightly confused why the professor thought it was a good idea to showcase this right now. No idea what the hell, or why the hell the professor thought this was a good question. Um, yeah, so we need to also talk about intensity. The square of the amplitude is the intensity. So the last thing was intensity, which I again this is, I'm saying this right now because I got this part wrong. Honestly, I did not expect this to be on the test, but you know. So next time it's the you want to. So is intensity or brightness is the it's a square of the amplitude determines the intensity, which um, or brightness is the square of intensity. And this was for Chem 6A, which is why I'm so more confused than ever. But, there probably was a reason for that. So now we need to talk about radio to gamma ray. Gonna be fun. Not really fun. I just need to figure this out. So, first one that we generally love to talk about is the visible spectrum over here, which is a very thin, tiny line um, that we all see. It's like a very sliver. This is the visible part. Um, Visible light is what it's called. Uh, and what so we're going to go radio over here. We're going to do gamma ray over here. So let's start with red as our we kind of red is here with 700 about. Next is orange. Do I have enough space for this actually? I never considered the space being a problem, but it's a 700. Yeah, I don't like that. So it's basically this units are Hmm. I don't like how I wrote this. So it's a visible light per nanometers. Yeah, so this was on my test, but this part I get. This part over here makes sense. This part over here, why chemistry needed this frequency shenanigans with the amplitude, the brightness was a little iffy at best, but it wasn't a lot of points, so I didn't really care. But yeah, that was interesting, I'll say. Um, there's not enough colors for me to say everything here. So you know what? I'm gonna go to orange and say yellow is next because no, orange is next actually. It's just following the rainbow. So I believe this is orange. So this is 620. Just think of the orange colors, which is yellow next. Yellow is next. Yellow is next. Yellow, which is like 580. Next is I forgot what color is it. Green. Yeah, green. Um, and I made a first mistake here. So the fact that I did not divide this properly into sections, so violet is very small. It's like a little tiny piece. Blue is the next big. It's a little bigger, and then there's a green portion that goes all the way to the middle over here. So I can actually space this out a little bit better by doing this. Okay. I need to visually show how broad something is, right? So, very interesting. I want to show green being a little bit bigger than all the other ones because green is big. It's just that, okay, fine, I have to do something like this. Green is big, and then there's something like this, and this part over here. You see, violet is very small, so I'm trying to make it very small as possible. Over here, after the middle point, there it goes a little bit of yellow, so like a tiny bit of yellow, and then a little bit of orange, and then the rest is red. So that's more likely the color spread. So I could say orange over here, then 620. The next one is yellow, um, which is about 580. Uh, yeah, and the next is green, which is a big portion. Um, Green is like 530, and the next one is blue, which is about here, this big. Blue and violet is so similar that I don't understand why people consider them different colors, but they do. Um, Over here, by such a similar color over here. Now, I'm always confused, like why do they consider this different? Violet 420. It's such a small difference over here. But you kind of get that general idea. And also it's flows, so there's no barriers. I just tried to make barriers to make it look presentable. That's so without the flow. Violet. Oh my God, eraser. I don't like how this is how it works. There's a violet 420 because it's supposed to be a fluid. It's supposed to be a mixture. Red and orange is a gradual change. It's not a big change. It's a slow change from each other. It's not supposed to be like a rapid place. Now the next few things is a little more rapider. It's all right. Let me check my notes. In my notes, they have it here. Yeah, it's a little less rapider. Yeah, it's a little more defined. After that, it's a little bit more defined. So we can say this is one ohm meter. Nano is it nano micrometer is next. Yeah, so this is actually the wrong way to define it. So this portion over here. So let me grab a black ink because we can't see it. So there's no point in coloring it at all. Um, so there's a certain place over here. So actually, this goes on forever. We don't really know what. I mean, I'm pretty sure there might be scientists that know, but I don't really know what's after this. There probably is something after this. So I'm just gonna write continue strip because that looks like no, I don't like how they do a smiley face. You know what? I'm gonna make a white over here so there's like ambiguity if it stops here because I don't know if it stops here. It might been not stop, but over here I know is radio. Radio is what we say, and this is 10 centimeters. Now it's important to note that it is not nano, which means that's a big radio. That's a big wavelength over here. Which I should probably say this over here is wavelength because I don't explain what wavelength is and I can visually show it. So over here is microwaves, which you know what? I'm just gonna take a little bit more space over here and pretend, you know, even if it's supposed to be, a small thing, I can just pretend it's more bigger. And then infrared, infrared, infrared. I think it's infrared. In infrared light, which is microwave is a light form, I guess, which is 1 meter. And the next is ultraviolet light, which is pretty big. It's about this big, I say. It's not as big as the infrared light, but it's pretty big. It isn't so it's ultraviolet, and you can kind of get the sense of where the violet light comes from. And we can say that it's pretty violet. Yeah, and you can kind of see why blue and those colors is more powerful because more seems more powerful because they have more gamma energy. So when you look at something that's bluer, there's no sorry less not gamma energy, sorry, less wavelength. It has wavelength is shorter, so it makes I'm just saying things up. Uh, so next one is X-ray, which causes cancer. Um, if not done properly. P is petameters or something. I forget. The last one is gamma ray. Gamma. I can't spell gamma right. Um, gamma. Gamma. Uh, gamma. I don't know how to spell gamma correctly. X-ray and gamma light. Gamma. You know what? I'll put it there like that, and if I get it wrong, I will fix it later. And then that's pretty much it with the light scene over here. We can save this and then save this as over here. Let me place that, yeah. Let me place that, whatever. And I think I'm gonna put it under here. Oh, under here because it's not that bad. Put it there. Gamma. And if we, yeah, that's pretty good. Okay. So we got that down.